So, all right, so let us get into it. The main event, and that is data literacy. So first, I want to kind of outline to you, as I said before, we're going to be covering a lot of topics in the course of an hour. And yes, this will be recorded, but it's always better off live, so don't drop off now. So this will be recorded, and you will have access on our AI Plus training platform. So Ira, who does an awesome job facilitating these meetings, webinars rather, she will make that available to AI Plus subscribers and email that out to you, and you can just log on there, and it'll be freely available there. So first, I want to cover what's possible with data literacy. Like, why do we care about this subject? What are we going to do with it? Next, we want to look at the data life cycle, and we're going to ask some very, very may seem like simple but fundamental questions, such as what is data, understanding different data types. I'm sure as Excel users and Google Sheet users, you're familiar with some of those. But then we move quickly into sourcing and collecting data, because all machine learning models, the data needs to come from somewhere. Sometimes it's external, sometimes it's internal. And then, of course, we look at data collection tools. What if you want to do this yourself? How best to do it? Next, we will look at data profiling, look at some example Kaggle data sets, as well as some examples, and talk about what we call outliners and correlations. Two important terms there. Next, we will look at data preparation, which is very important in the whole machine learning data science workflow and life cycle, such as data transformation and data enrichment. Then we'll move into this term we like to call data shaping. You probably already do this, but we haven't put a label on it. Want to look at some examples of data shaping, some of the tools you can use. Look at something called, you've all heard about big data, but what's big data versus shallow data versus wide data? Important to understand that. And lastly, we do have a follow-up webinar for this in March. It's called AI literacy. So first we do data literacy, so you can understand the underlying data behind models. And then we move into AI literacy or machine learning literacy. I think I want to rename that machine learning literacy. But we'll get into a little bit about that, because all this data leads into what we call features and feature selection and feature engineering and feature examples. So that's pretty exciting. So, and then I got a few free resources I would like to share with you at the end to help you on your data literacy journey. So, as mentioned, we're going to define it first. So as we go through this tutorial, what I want to do is kind of define a series of definitions, because literacy is key to that. And if you want to understand what is data literacy, it's building a vocabulary and insights that allow you to speak data. Can I speak data? So data literacy is the ability to ask and answer meaningful questions by collecting, analyzing, and making sense of data. And that's an important definition, because if you internalize that and understand, how do I ask questions? How do I pose this correctly? So asking questions about data is very important. You may be a data scientist already, you may not be, you may be in a different domain. Do you want to be able to ask questions, not about, and again, we're not talking about asking questions about AI or machine learning or data science here, just asking questions about the data. Where does data come from? How did you collect it? What methods did you use to collect it? What tools you use to collect it? All those questions that you'll find out shortly are very important questions to ask about data. And then data literacy will help you, even in this one short hour, you'll be able to learn how to interpret data. So when we start talking about data transformation, data profiling, this will help you start to understand how to interpret data. Another key thing that data literacy can help you is understand what data and AI experts do. So let's say you want to join the ODSC mini bootcamp, or you're doing stuff on Coursera, or you want to a data science degree, machine learning degree. Understanding what folks do with data before you actually get into the field and go headlong into it. You may find that you're like myself and become a complete data nerd. You may say, this is worse than watching paint dry, and I can't really stand this. So understanding what the experts do with this data will really help you understand some core fundamentals to what that job entails, and also perhaps some misunderstandings and myths around the field. And this is very important, because I'm a huge believer that there are tons of jobs out there available in the data sphere, in the AI sphere, and it's not just about everyone becoming a machine learning expert or a data engineering expert. Let's say you want to be a project manager and work on AI projects. Let's say you want to be marketing for machine learning and data science or AI, or you want to do something like you want to be a writer. You want to, there's tons and tons of job opportunities available in the AI field, and they'll grow and grow and grow. And the common denominator amongst all of those is just being able to converse with data experts. Like, you don't have to pretend or try to be an expert yourself, but being able to ask the fundamental questions, being able to write about it, being able to speak to it, you can still do that without actually having to be statistical experts or machine learning experts. So that's very, very important. So that's an important subtlety we'll get into. And then, of course, as mentioned, we'll get into more details. Like, let's say you want to prepare yourself for a career. So understanding data literacy can be very, very important for that. And also, I was kind of inspired to do this tutorial because I think there's a lot of great data literacy content out there in the web. Like, there's a course on Coursera, there's a course on Udemy, there's stuff on YouTube. But what I kind of found out that each of those courses have a different context. So I think the one on Coursera was very much geared towards statistical analysis, which is great if you know statistics or you plan to study statistics. But I wanted to use this as a foundation tutorial for a career in machine learning, data science, and related rules. Because what you can do with this data literacy is you can discover and take advantage of trends. For example, we'll look at some time series data on the stock market a little bit. So trend analysis is very important. It's also fundamental to understanding how prediction models work. So I kind of sometimes bill myself as a data science or an AI expert, but the sad truth is I'm still a student of data science and machine learning because it's such a vast field. You're always learning, right? And I'm still trying to understand the many, many models out there, machine learning, deep learning, predictive analytics, and whatnot. But at the end of the day, all of these methods and methodologies have one thing in common. They use data to drive their models. So understanding data, it's awesome because you can get quite far in your career or being a citizen data science just by understanding data, which is the easiest part of this whole methodology. So don't worry about the algorithms, don't worry about the math at start. Focus on the low-hanging fruit, the easy part, which is basically just understanding data. And this is awesome because even using a simple Excel spreadsheet, you can find hidden patterns in data. This is one of our favorite activities. We're always looking, what is the data going to tell us? Forget about modeling it or predicting on it. Like, just see what the patterns are in the data. Because remember, what machine learning does, we'll talk about this later, especially in the machine learning literacy or AI literacy, is what machine learning does, it finds patterns in data. It just automates that. But you as a person can do that manually, right? And then that will help you understand machine learning and data science models, because you too, now you know that you're looking for patterns and machines should do that as well. If you're in your job, we use data for identifying risks and threats. Like, all cybersecurity is based around, it's data driven. But again, on the more positive side, you can use that to identify new products and services. Like, we use a great company out in San Francisco called Channel Human. They use a lot of data to understand, who should we be marketing to, what our personas are, and all that kind of stuff. And definitely another one is, customer experience tends to be based on call logs, chats, and stuff like that. But there's a lot of data you can use to improve customer experience. And this is of primary importance because we can get into the definition of data science, definition of machine learning, and all that stuff. But let's just look at a simple definition of what is data science. So data science is statistics or some kind of math. It could be linear algebra or calculus, but it is some kind of math, statistics usually. It is code. So you want to be a data scientist, usually have to do some kind of coding, Python or Scala, Go, what have you. But most definitely, data is fundamental to data science. And as I said before, you learn the data part of it, and you've got 1/3 of that equation as to being a data scientist. So that's the good news there. And data literacy is also prerequisites for, this is a kind of take on Drew Conway's famous data science Venn diagram. But when I look at that and I look at the whole data science, machine learning, data ecosystem, these are all the fundamental parts of it. Like, you've got data modeling, you've data engineering, you've got data visualization, you've got math. Again, that's usually for machine learning and data science, we focus on pretty narrow bands of, linear algebra, calculus, and statistics and probability. And then, of course, data analysis and then data programming. Like if you look at our mini bootcamp and stuff like that, we do a lot of work with pandas and stuff like that, which is basically kind of Excel for programming, because you can do a lot of quick, cool analysis there, and we'll show some examples of that later. And again, just focusing on the data part of this is very, very, very powerful, because now you can start to look at fields such as data analysis, being a data scientist, machine learning and deep learning engineer, software developer, data engineer, data journalist. And getting away from the STEM stuff, looking at data journalist, management, AI project management, the whole new field of data governance, data compliance, responsible AI. Again, just being data literate and being a student of data and nothing more than that. All of these opportunities and fields open up for you, whether it's a professional opportunity, a career opportunity, or just a hobbyist or a citizen data scientist or something like that. And again, this is very important to us, because if you went out today and looked at our ODSC Boston conference coming up, you'll see that we organize our conference around tracks and focus areas. And you'll see we've got machine learning on there, we've got data engineering, we have NLP, research, cybersecurity, big data analytics, responsible AI. And every one of those rely on fundamental factor, and that's being data literate. So whether you're attending one of our conferences or somebody else's, being data literate can go very, very far in terms of accelerating your learning and ingesting that stuff. So I want to talk a little bit about the life cycle. So life cycles in engineering and other disciplines are super, super important. We talk about the machine learning workflow life cycle. We talk about the research life cycle. But here, let's talk about a variation of that, which is data life cycle, right? So it's a series of stages that data goes through from creation and collection to usage and reuse in data analysis, data science, or some other methodology or service, right? So what's cool about this is this can be applied to lots of different things. So let's take some examples of that. The first part of the data life cycle, and this is universal, you have the data collection. Data has to come from somewhere. It doesn't exist in the vacuum, right? We have to define the data. We either have to find the data or generate the data. And then we have to capture it, and there's this cool concept called exhaust data. So every time you're on your laptop, or there's a computer server out there generating all these kind of log files, it's generating exhaust data. So a lot of people are starting to find value in exhaust data. So first part is data collection. Then the next part is I've collected data. Right? So what is the data I got? We call that stage data profile, and we'll go into this in more detail. Is the data reliable? Is it consistent? If I'm trying to scrape data from the web and I start it and all of a sudden I get blocked from scraping, so it's no longer, it's not reliable. Or there's way too many inconsistencies in data, or it's garbage, right? So that's what we do with data profile. We basically take a microscope to it, or a magnifying glass, we show here, and figure out is it useful or not. And the next stage is, okay, we got some useful data, but that was just from a profiling. We took a glass, and now we have to transform that data. So we have to normalize it, as a term we use. We have to transform it. Let's say you're getting data, date time data from Europe and from the US. It's in a different format. You got to make the month, day, year kind of uniform. We'll talk more about that. And then next is, now we kind of get in the fun part, is we want to analyze and model data. So we want to do things like feature engineering, feature selection, good stuff like that. Some stuff that we won't cover today is we won't kind of get into making predictions or visualizing data. Making prediction is our machine learning literacy is all about making predictions, as well as all the content you'll see at the expo and stuff like that. So very important to understand, because usually if you're working with data, you're loading into Excel spreadsheet. There's really you're thinking of two steps: the data collection, not even the data collection. You're like, someone sent me a spreadsheet of data, so I'm going straight to the analysis. I don't have to do any preparation. I don't have to do any profiling. I don't have to do any collection, but there is a few steps to that. So this is kind of like what a data scientist would do, which is different from a data analyst working on a spreadsheet. And again, this is kind of like a positive feedback loop here, or maybe it's not positive, but it's definitely a feedback loop. So the stuff that when you make predictions, now this becomes part of your data collection, because now that's new data that you can define and profile the data, like are the predictions reliable, are they any good, do I need to transform the predictions and stuff like that. So it all feeds back into it. So to get our head around all this stuff, we're going to use a super simple example. So we're going to use this example right throughout this tutorial. And the one I want to use is house or apartment listings, because we're all familiar with that. You may be still at home living with your parents, but you at least know what your dwelling is. Number of bedrooms, number of bathrooms, your location, the square foot meter, square meters, or square feet. That's all very important. So it may be that you've rented an apartment or looking to rent an apartment. But again, this is a very approachable kind of data set. And this data exists everywhere, right? There's tons and tons of examples of this. So this is going to be very important. So think about all this data, the address and all that good stuff. And what we're going to use here is, as you can see from this list on the left-hand side here, all of these are all kind of important variables, data points. And we have another special name for them later, but the list price, the size in square feet, the price per square feet, number of rooms, number of bedrooms, number of bathrooms, type of house. There's a central layer. When was it built? When was it parking? So some of the stuff you might not care about if you're renting. You don't care about what year it was built. You walk in, does it look good or not? If you're buying a house, especially here in New England, a lot of very old, crappy housing stock. You care about the year it's built, or does that parking and whatnot. So these are kind of our data points, our variables, our factors. We've got an names for them. And I would encourage you right now on the bottom right side here, you can Google it. This is a great Kaggle data set. So Kaggle is a great place for finding data. We'll talk more about data sets later. But if you Google Kaggle house prices, advanced regression techniques, don't worry, we're not going to be doing advanced regression techniques today. Instead, we're just going to go to, if you go to that page, you click on the data tab, and then you'll be able to download a very, very clean set of data. And the objective of that data was to predict sales prices, so it's going to have a lot of that data we need. And if you look at it here, when you download it, and you don't have to do it now because I'm going to walk you through it, but sorry, I should probably give you a second there to do that, so you can kind of play around with that. And just check my time here. So yeah, hope you had a chance to go check that out. Go download it. And so moving on here. Again, we've got a pretty good quiz. Actually, let me just check if there's any questions. So I assume my screen, someone asked a question, can I share my screen? I will assume my screen has been shared for the last 20 minutes. So please let me know if it's not being shared. And there was a question about feature engineering. We're going to get to that. And will this be recorded? Yes, it will be recorded and be available for you. So getting back to our data set here, if you download this from Kaggle, you'll see it's this is pretty nice and clean. They look at this thing called lot area. It doesn't have a unit measure on it, so I assume that's square feet because this is an American set. It has a name of the street, building type, condition, year built, heating, central layer, full bath, and all this good stuff, right? So pretty clean data set, and we will get into what all of these mean in a little bit. So what is data? So again, getting back to fundamental definitions here. So data, and this is from Wikipedia, data are units of information that are collected through observation. In a more technical sense, data are a set of values that are qualitative or quantitative variables. So you've all heard of qualitative and quantitative variables, and we'll go over that. So now, like, this is like peeling an onion. All right, so I'm using a word like a variable. What the hell is a variable? So what a variable is, it's a placeholder for a quantity that may change, and that's the name is a giveaway. It varies, something that varies. So if you're looking at apartment buildings, number of bedrooms in the apartment, the first apartment you looked at might be 2, the next one might be 1, the next one might be 4, right? So these are, we call them variables. And values of each variable statistically vary are distributed across a variable's domain. And a domain is a set of all possible values for a variable is allowed to have. So this is very important. So if you look at a data set we got from Kaggle, you will see that that particular data set had a column called central layer. And the values there were yes or no. Maybe the values could be yes, no, don't know. But for that data set, it either said yes or no. So the domain of variables for that column is Y or N. So when you study statistics, when you're looking at data, when you're doing SQL, the domain or the distribution of data is very, very important point. So again, quite simple definition, and you can get some very boring mathematical definitions of this. But again, think of that. Just think of a simple example. And then another example is another great one to think about is year built. So if you're looking at new builds, people tend to think that with year built, it's like I would ask you a definition. If you were to program this, what would you give a definition of what's the distribution or the domain of year built? You may say from 1920 to the present day. Then you're wrong on that, because there's plenty of housing stock that was built in the 17th, 18th, 19th century around the world, even earlier. And then lots of houses and apartment building, they're advertised in the future. So somebody may be building a housing apartment, they're selling it now, but it's coming available in February 2023, not February 2022. That's kind of the kind of issues that helped us get into Y2K trouble, if you remember that. So again, so what is data? So data is a variable that can be qualitative, quantitative. So quantitative variable is numeric. It's discrete. You may count it. How many bedrooms? You don't have a half a bedroom. You don't have a half a person. You know, it's numerical. It's discrete. Can be counted. And then there's other variables, continuous, like what's the person's height, right? It's continuous. There's no discrete value there. Quantitative data, generally speaking, can be collected by instruments, and we have to collect that data. It can be done by sensors. Often it has a natural order, and it comes in standardized units. So you know, if you look at stuff like distance, for example, is continuous, and standardized units might be something like you know, if you're looking at the state the house is in, like they use standardized units like for state, like MA for Massachusetts, NY for New York, and stuff like that. Meters, feet, and all that kind of stuff. And it's often structured. Qualitative variables, on the other hand, are a little more fun. They tend to be non-numeric and descriptive. So you want to describe a house, you'll say this is a red brick house. It's large, it's beautiful, it's dilapidated, whatever. It's categorical, right? It's a condo, it's an apartment building, it's a house, it's a semi-detached, detached. So generally describes qualities or characteristics, and is generally collected via observation. So see the difference there, collected by an instrument or logging versus collected by an observation. So a lot of times people, they even when you're looking at housing data sets, when you do something called a housing assessment, an assessor will come in and he will rate, they will observe the condition of a kitchen or a house or something like that, and maybe rate it and say this is good, bad, you know, poor, and all that kind of stuff. And this data is often unstructured, and we'll talk about that. It could be a picture, it could be an image, it could be text, it could be whatnot. And here's a little joke from Dilbert. So what is data? So he's like, I have the ability to quantify the unquantifiable. This is why they call me Doug, but the quantifier, who calls you that? 8 people. So, you know, kind of a bit of a joke there on quantifiable versus unquantifiable. So anyway, so let's get an example here. So quantitative data. The year was built in the house, 1930. Number of bedrooms, 7. Square foot, 2,500 square feet. And the other example here, qualitative data. This is a brick house, I believe, brick facade, whatnot, red brick house, red exterior. That's not my house. I wish I owned that house. That's a pretty good looking house. But so you could say some people like, I don't like brick, but that's a, you know, one may describe that as a pretty nice house. All right, so moving on quickly here to data types, and this is a little bit of the boring bits, but we covered it anyway, because again, if you use an Excel spreadsheet, you kind of notice some of this, because how you manipulate and transform data is very, very important. So when we start to look at data transformation, data profiling, data shaping, usually that's determined by what type of data you have. So binary variables are very simple. Yes, no, true, false, heads, tails, right? You use those in probability, cool stuff like that. It's 1-0 outcomes. Nominal categorical data, these are values that can be ordered. Colors, types of pet, cat, dog, hamster. Ordinal variables, ordinal, order, educational level, right? Let's say you're doing analysis on, you know, applicants to your master's program. Do they have certifications? Do they have degrees? What kind of degrees and stuff like that? Quality rating. And then I want to talk a little bit about this because this is some of the coolest data out there is time variables, time series data. So stock prices are good examples of this, and we'll go on to that in the next slide. And then, you know, count variables, like people think this is oversimplification, but count variables are very, very important in machine learning data science. These are discrete whole numbers. You know, lots of data has our best use count variables. And then, of course, random variables. We want to generate data. We want to do probabilistic analysis, statistical analysis, probability, and random variables are very important for building Monte Carlo methods, all kinds of good stuff. So time series data is quite cool because most of my earlier career was in finance, working for companies, and then I did a lot of consultants in it. So, and time series data is massively, massively useful. Pretty much in your company you work at right now, in your budgeting, everyone has use for time series data. So time series data is a set of repeated measure observations collecting the constant time intervals, such as hourly, daily, weekly, monthly, you know, whatnot. The key thing there is it's constant time intervals. So you can't collect data 1 week hourly and then switch to weekly. Then you're going to have to transform your hourly data into weekly data. So, you know, it's got to be constant. It's got to be the same time period. And it's quite hard to do, especially if you think about collecting data and all that good stuff. And what you get is a time series chart like this. This is actually, what is that? That is, oh yeah, I know what that is. That's Bitcoin for you crypto enthusiasts out there. Unfortunately, actually, I don't know where it is currently. I do dabble in that a bit, but not lately. You know, what do you guys say? Diamond hands and all that good stuff. So time series data is pretty cool data. It can just be forecasting stock movements, sales by months, power demands, price of goods, passenger numbers. One of my side businesses with my my siblings years ago, I used to have a series of restaurants in Ireland, and what we would do was you know, I couldn't understand some of their forecasting models for ordering foods and stuff like that. So being a programmer and engineer, I started to build them. You know, I would just look at the data by how much was ordered, how much was consumed, and started to build them models based on simple time series models based on the day of the week, Sunday, the weather, and stuff like that. So you can do a lot of great stuff with simple time series models. And in addition to that, like you can do what we call time series analysis and time series prediction or forecasting. And let's say, for example, let's say you were I can't move this. This blue line here, everything to the left is the data you had that existed. So could you forecast the price of Bitcoin? And I can tell you, having worked in finance, a lot of models in finance are what we call momentum models, which are pretty close to mean average models. And hell, you know, I'm not trying to be a technical analyst here because I don't believe in technical analysis for technical analysis, a type of financial modeling. I'm not a big fan of it, but you know, mean reversion models would probably tell you that's going to revert to the mean, which is somewhere around here. So the simple mean reversion model, you could probably say it's going to go down. That's a mean reversion model on this line here. And with a momentum model, you can say, well, it's our market model. It's been time series model. It's been going down, so chances are it's going to go down, and then you'd be yelling at me because it went up here, and then it start going down again. So you can kind of get quite far with simple prediction models, especially if you're a day trader or you're looking for quick wins. We always say don't go against the market. And that's what a momentum model is. You go with the market. But don't give me grief if you start losing money on Bitcoin, because I can't tell if it's going to go up or down, but it will go some ways. What it's not going to do is go sideways. That's all I can say. So again, just to reiterate that point, many analysis and forecasting problems involve a time component. Time series analysis involves developing models that best capture or describe the observed time series in order to understand the underlying causes. So that's looking at past data to understanding why this happened. Time series forecasting involves making the model fit the historical data and use them to predict future observations. So we'll talk a little bit about this in our machine learning literacy thing, but that's super cool. You can use it for machine learning modeling, statistical modeling, and deep learning, like with convoluted neural networks or LSTM models and all that kind of stuff, which we'll get to in the later series. So let's look at data types. This is very important to understand. So machine learning, deep learning, NLP especially, allows to make your use of unstructured data. So we looked at the Kaggle data set. That was an example of structured data, right? But unstructured data takes lots of formats, and this is what makes machine learning and data science and deep learning so bloody exciting, because now I can do modeling based on video feeds, based on music. By the way, based on images. I do have a lightning interview coming up with a AI artist, an expert in that on Friday. So tons of super cool stuff happening in AI and art. So if you want to check that out Friday. And really, it's all about using this unstructured data. So text, audio, email, IoT, and social media. So these are all forms of unstructured data. And the cool thing about unstructured data is it doesn't matter how much structured data will be in the world. There'll all be 5, 10, 20x of unstructured data. What does it matter how many x there is? Just the main point is this will always exist in much, much more volume than structured data. So there's a lot to work with. It's cool media to work with, and a lot of stuff to do there. So, but that's important to understand, because when we're collecting raw data, we oftentimes do not collect it in a structured format. It doesn't just show up in your inbox in a pretty CSV file. A lot of times it's unstructured data. So you see here on the right, these are log files, an image collage. So it requires profile cleaning and standardization. And captured data is what we call, it's found through purposeful investigation or analysis. So let's say you want to build models for doing marketing, and you're going to, measure clicks, put stuff on your website to measure what people are doing. That's called captured data. Exhaust data, which is also kind of cool. It's exhaust data gathered by machines as secondary function. So let's say people are uploading image to your image gallery, and exhaust data maybe where they uploaded it from, what time they uploaded it, what day, and you may say, hey, I built a model, and people tend to upload images on Sunday morning for some reason, or a lot of images tend to come in the summer because it's nicer outside and people are taking more selfies and whatnot. I don't know. So a silly example of kind of what exhaust data can be useful for. So it comes from log files, from sensors. It's often stuff data that's thrown away, and all of a sudden you find a use for it. Social media was never measured, never modeled until someone said, hey, we can actually build models based on social media data, like text. A lot of text was like, we can't do anything with text. We can't run statistical analysis on text. But when machine learning and deep learning came along, all of a sudden, yeah, we can do a lot of stuff with text. And this is a great image from Monica Baggiata. She's got a great Medium blog post, by the way. It kind of shows this pyramid, like, yeah, everyone goes straight into deep learning and AI, A/B testing, analysis, all that stuff is cool. But look, at the end of the day, the foundation for all this stuff is collecting data and then moving it and transforming it and then exploring it and all that stuff, and then labeling it. So this is again why I say most of the work is done exactly what we're talking about. So let's talk about data sourcing. So when people talk to you, and again, this is about talking to data experts. If someone comes to you and says, hey, Joe, Jane, John, I got a great model. Well, okay, where did you get that data from? Did you source it internally? Did you get it from our data store? Did you get it from a text? Is it private, confidential? Images, was that internal data, internal to your project, your company, and stuff like that? And then, of course, there's external data, which a lot of us gets it from. It might be from an API source. It might be from open data. It might be from licensed data. But you should question every one of these, because trust me, most machine learning, deep learning, and AI models, they run into problems right here. Internal data. Where was this gathered? How was it gathered? These are good questions to ask. You got that data externally, like at ODSC, we've got a whole thing on machine learning safety. Like, I know I don't want to sound alarmist. Well, what if this data was poisoned? This thing is poisoning data. Someone could lay a trap out there. They could say, well, for this kind of data, I'm going to put a bunch of junk on Wikipedia, build these crap websites, and these external data scraping things are going to pick up that data and it's going to influence the model, right? if I want to say Seamus McGovern is, let's say someone was building a model on best photographers in the world, and it does it by scraping social media. I could build all these fake profiles around how I'm one of the best top photographers in the world, and this model, because it would scrape all that out data, would think I'm a great photographer. So think about that. So understanding sources of data, how they're sourced and what they're sourced of, is very, very true, very, very important to all this stuff. And then external data is pretty cool. There's so much out of there. It's the whole thing about open data is available to all. It's provided by individuals, governments, and companies, right? So you look at any kind of open data sources. On the other hand, non-open data, to add a simple definition of it, is it's not it. It's closed. It's private or proprietary data. So you got to be careful about this. You know, you might have IP around it. You might have non-disclosure agreements around it. You can't just take your company's data and make it available on the web. That's a good path to a lawsuit. And the problem with non-open data, again, like a lot of companies have legitimate business around this, but the problem with it is it's collected from many people by the few. So think about, not to name names here, but just look at those logos. You get my point, right? So it's great for those companies because they can use it, but nah, you can't. So another thing to understand too about licensed data, you got to be careful about this, because I'm a huge proponent of open data science. Conference, we built it all around that. The problem you have these days is not only do you have this definition of open data and closed data, but now there's a thing that exists in between. It's closed proprietary data, but we'll give it to you, but you have to pay for it. And that can get very expensive. So that's why we say data is the new oil, because it is bloody valuable. So data warehouses, targeted ads, credit reports, all of these things. If you want to start your online bank and want to give out loans, you want to get credit reports, you're going to pay a lot of money for all that data. So they're scraping all this data that's available out there. So when people talk about, privacy advocates talk about, look, it's your data, you should own it, they are damn right, because a lot of people are making a lot of money off of your data. So open data. So let's go back to the positive here. So many sources are positive for open data. It's great for research or training, but the problem is there's much more non-open data than open data. So if you're learning and researching and all that stuff, but trust me, I don't know how many projects I've had where the CTO or the chief data science company be like, Seamus, we need data for people who switch jobs. Let's get data on that. I'm like, okay, well, the sources are LinkedIn, bank data, mortgage data. And I said, by the way, none of those are open data. Just because that data is available on the web, it may be against the terms and licenses. Scrape that data, number one. And two, it's not just some magic spout you can go for. So it's great data, it's great for research and training, but just be careful when people tell you that they've sourced open data or they've gotten open data, question how they got it. Is it consistent? Is it going to be reliable? Does it break any license agreements? So we're very careful with that. But having said that, Wikipedia is a great source, tons of data sets out there. One of my favorites is GitHub. So if you're a programmer, code first, you know all about GitHub. But GitHub is not just about coding, tons and tons of data sets out there. The time series data sets I showed you, Fred has something like 1.2 million data sets out there. And this is a great example, like nothing against Bloomberg and FactSet and all that stuff, but Bloomberg, FactSet, market data, you know, they take all this data, they add it to other stuff, and then, you know, Bloomberg Terminal is $2,000 a month, but you can get this free data for yourself and play around with it. You don't have to pay for it. So it's all available free. Kaggle's got awesome, great free data sets, and even Amazon, to their credit, I wish they would do more, but they have what they call the Open Data Registry, which started a couple of years ago, and now it's not as active, but they've got data on there. So if you're doing research, looking around, these are lots of great data sources. And then, of course, come on, what about collection tools? You want to collect your own data. So if you're a code first, learn Python. Tons of great sources in Python. R as well as good as, there's this great platform that's been around a decade, use it a lot, Beautiful Soup. Funky name for a great platform. There's other ones out there. Scrapey is another one. That's the name suggests. You know what that does. So if you're code first, this is great. But even if you're not, believe it or not, Excel and Google Sheets have great things. Like in Google Sheets, you can go right to a website, and if the data is available and you're not breaking the license agreement, you can do import XML, import HTML. That's a good one. And then one of my favorite tools, which is a little tricky to work with, but there's this thing called Robotic Process Automation. We've used it a lot in testing. When you test a website, you got to test the website, which, you know, put a load on there of maybe 100,000, a couple 100,000 users. But RPA was originally used for automating test sets, but now there's a cool free one out there called UI Vision. We use that a lot. And no code. You just point it at the website, click at what you want, it'll generate the script for you, and then it'll start scraping the website for you. So if it's not in a tabular format, if it's in a tabular format on the website, Excel, Google Sheets will work great. If it's not, if it's pretty unstructured, then you can use RPA tools. And again, you can do that with it's no code or low code. And you guys are super lucky as well, because a lot of times when we started doing ODSC 5 years ago, it was very much a code first environment. You had to be super proficient in R, Python, but a lot of platforms and tools now are going to what we call a low code, no code. So meaning you don't have to be as code proficient to do all this stuff. So tools like RPA are definitely low code or no code. Let's move on to data profiling. So data profiling is an important preliminary step before data preparation to explore data. And the goal there is to determine if your data is complete and accurate enough to build good models. Again, right? So just making sure, and again, you can use this even if you never want to build a model. If a data scientist or an AI expert is coming to you and saying, hey, I built this great model, well, you can ask them kind of questions around their data profiling and what they did there. So, and remember, pretty simple definition. The old adage we use in technology, garbage in, garbage out, right? Garbage in, garbage out. And definitely if your data is garbage, your models are garbage at best. At worst, they are very dangerous. They will ruin your career or your company's career, because you know, you can't tell someone who's not got cancer they have it, or they have cancer, and you tell them they don't, you know, or vice versa. And we've seen lots of examples of that over the last few years, and this is going to happen increasingly because people are not paying attention to it. And the problem is, you know, I went through the financial crisis, and the problem there was you had too few people looking at too few models and too few data, and they were actually, the models were good. The problem with the models was they were modeling on 10 years of positive data. The prices of housing was going up back in that period, and they were only using positive pricing data. They never looked at the negative data, and the whole financial Lehman collapsed, and all this, the history of the quant collapse is very interesting. So models are only good as the data. So you want to analyze your raw data to get a better understanding of its usability. So and figure out what insights it can provide. And remember, data quality is just as important as data quantity. You can do lots of stuff like with T-sets and stuff like that with low data. And it also is a very important step, because lots of times I look at data and say, you know, I'm not going to continue with this project or this data science project, because you remember back to that, your boss, you work at a, let's stick to our housing example. Your boss say, hey, Seamus, I want to predict house pricing in Canada. I'm like, I got no data for Canada, and it's going to take me 3 months to scrape that data, or we got to buy it. So either give me 3 months to scrape the data, or give me $50,000 to buy it. And you know, your boss may say, pass, right? And end the project. So, and this is what we call another important thing to understand about data science projects. Like if you work in software, marketing, stuff like that, we're used to segmentation. We do the requirements phase analysis, then we do the design and discovery, and then we do the build out. Data science, machine learning, deep learning, they have what we call the pilot project phase, for lack of a better thing. You have no idea if the model is even going to be any good or and work anything until you kind of conduct small little models, small pilot phases. And the first part of that is, do I even have the data to build this? And what does that data look like? So again, sorry to keep talking about that, but data profiling is very important. Being a data scientist and being the life of a data scientist. All right, so enough about that. Let's take about some examples. So this I think is cool. So let's go back and profile the Kaggle data set. So we're going to look at something here. So first of all, this is a pretty small data set. It's only got 1,460 rows, right? It's structured as mentioned, so it's all organized, so we don't have to structure it ourselves. And these are 2 important points of it. So if I was to take that data and run a super simple analysis on that on Google spreadsheets, or do something simple like this, we build what we call, just map the data out, right? It is kind of time series data, as I mentioned here. You will see that this is a distinct shape. It's a pretty famous shape. It's called the normal distribution or bell curve, and you can see the prices are on the x-axis, by the way, and the frequency of that is on the y-axis. And then we can start to look at stuff like what's the mean here, what's the middle point of this data, and this is, if you're a statistician, you may know that this is not quite a normal distribution. It's skewed, and skewed means it's in this case, the data is falling more to the right. And if you think about house price data, that makes absolute sense, because there's very few house prices that are priced very cheaply, but the average house price may be something like, in this data set, a couple of $100, 100,000 rather, but there could be plenty of houses that are priced 1.1 million, 2 million, 3 million. You can even see this one here is priced up as 7 million for some lucky person. And by the way, this chart is right skewed. And again, these are not hard definitions to remember. So right skewed means it's positively skewed. So most data falls to the right. And again, you know, thinking about the data, thinking about the chart was telling you, that seems right. So if I was looking at Canadian house price data, I didn't manage to scrape some off the web, and all of a sudden I'm looking at a normal distributed set, or it's left skewed, straight away without knowing anything about the data, I'm like, there's something wrong with this data. Or the average house price in Canada is like $30,000. Like, what? What's going on with that? So you can tell by, and by the way, this is a great example of what we call visual data analysis. And if you use something like Pandas, this is super simple. If you've never used Pandas before, Python, just download it, do it on Code Labs, and you use like one line of code. You import the data, which is, I guess, another line of code, your first line of code, and then you just do pandas.describe, and it's going to give you all this great stuff. It's going to, and we'll get into what features are in a minute. It's going to tell you the minimum sales price, the maximum sale price, the mean, the standard deviation, and all that good stuff. So I can see right here, like looking at percentiles, which you may be familiar with, but the 25 percentile, only 25% of house prices are around 130,000 or less. The 75 percentile, 75% of the houses are less than or equal to 214,000. And then what between the 25 percentile and 75 percentiles, these are borders of our upper lower quantiles, and then we get the 50% percentile, which is we see is 163,000 there. And that data as well, if you're a statistician, you can know at least 50% of the data is in the middle or the median. And you can also see that the mean is higher than the median. And when the mean is higher than the median, that is a definition of right skewed, right? So even without looking at the chart, if you know what the mean is and you know the median, you can see it's right skewed. And also the standard deviation is the general difference between those as well. So just looking at those, like if you don't know those, I'm going to share some books at the end of it, but just understanding, without being a machine learning and data scientist or something like that, just understanding the mean, median, standard deviation on basic data can get you very, very far without being a stats or a math nerd. Another awesome thing we love to look at when we look at data is outliers. You know, people may tell me I'm weird all the time, I'm an outlier and all that kind of stuff, or but in data it's got a different description. So you can see here, it's pretty simple. You use a similar technique in sheets and stuff like that, and you just plot this out with outliers, and you can see these. If you look at my screen here, this looks like a pretty regular linear regression plot here, and you can see these wouldn't necessarily be outliers because they're on the same mean regression line, but these here are kind of outliers. So what's going on here? So these are very large houses with a very low price, every buyer's dream, you would think. So with outliers, you got to determine what to do with them, because you may say strange, like you don't always keep data. So you have to figure out, do I keep these data points? Well, I'm going to keep them if they're correct, right? So you might want to check your data and say, were these mistakes? How do you figure out that? You might want to keep it a small sample size. Here we got lots of samples, so maybe we can toss these out, even if they are correct. We keep outliers if there's lots of outliers, because you couldn't say these are outliers because there's a lot of data points in this area because they're not up, so you probably want to keep them. On the other hand, you may want to drop them if they're incorrect. If you had lots of data, like it's pretty safe to drop these because we actually do have lots of data. You can go and re-verify it. So if it's like if you're collecting data from the website, you can go collect it. Well, let's collect it for a different day and see what we find. And you can also replace it with techniques called Windsorization is a pretty interesting technique you can also employ here. But just in the interest of time, I won't talk too much about that, and I'll go to it because I want to show you some other cool examples of what you can do with data. And again, we're not even doing any machine learning, deep learning stuff here. We're doing very, very simple techniques. So if you use the same pandas framework, you can do in your pandas library, if you import that into Python, you can do what's called the Dataframe Correlation. And these are pretty cool because we're looking at correlations between two entities. So this is, and again, a correlation, if you remember, if you don't know the definition is pretty simple. It describes the linear relationship between two variables. And by linear, we mean they change together at a constant rate. And that's what gives us that kind of straight linear line here. So on the chart here, this is quality rating versus the price, right? So you can see, generally speaking, this was done the quality rating. They were rating it, and they were doing discrete ratings, not continuous. So they're saying 2 and 3 and 4, giving a scale of either 1, 2, 3, 4 out of 10, right? Square feet is continuous here. So you can kind of see like as the size goes up, the price goes up. And these are all correlations to price, by the way. We say, forget about garage. The bigger garage you have, the higher the price. I'm sure if you ever used to watch MTV Cribs, you know that number of bathrooms, generally speaking, the more bathrooms you have, the price tends to increase. And this is an interesting data point here because you can say to your architect, you know what, I sold my Bitcoin, I'm building a big mansion here, but it doesn't matter if I got, the price doesn't seem to increase that much if I got more than 5 baths. So maybe we'll stick to 4.5 bathrooms. And then your construction is kind of like, you can see this is kind of all over the place because house may have been originally built in 1920, but it's been remodeled. It doesn't matter if it's in 1920. So you can see how that is not a strong linear relationship. And right now, if someone's telling me like what's the strongest indicator of house price, it's the quality or the square foot. And without even being able to see a house, because maybe you can tell from images quality. And again, this has led to cool models. So usually you would have to send an inspector around to gauge the quality, but let's say all the houses are on Airbnb and you've got tons of pictures of the inside of a house, you could be able to build a price model based just on images alone, or you can build a simple price model based on square footage, and that will get you quite far. So again, linear relation between variables, and again, they have strength and direction, right? So they have a direction that can be, this one could kind of revert and go from top to bottom and stuff like that. And these are all examples of positive correlators ones here. And then what they allow you to do is gauge impact. So again, using just simple data, you can get quite far in your trend analysis, find out what's going on, stuff like this. And again, you don't have to be a rock star data science and machine learning engineer to kind of get this stuff. However, just to get you understanding why you can become a data science and machine learning engineer, because most of the time you're going to be dealing with data issues. So if you get that data set, like remember, you may think bedrooms are discrete. You can have 3 bedrooms, but you can't have 3.5 bedrooms. Like that doesn't exist in real estate, but bathrooms do. Like there is such a concept as a half bath, which I never knew until I came to America. So a half bath would be something with a commode and a toilet in it, with no shower and stuff like that. Maybe I don't know what you call a shower with no commode or something like that. Bedrooms, like maybe you got there's no bedroom in the house, which is like all of a sudden you're saying, hey, what the heck's going on here? There's got to be a bedroom, maybe it's a studio, so maybe that's okay. Also, you can look at data like looks fishy. So if someone's giving you a data set, you can do some analysis on it. And again, we're doing data profiling. If I got 2 bedrooms and 6 bathrooms, that is pretty much a red flag that maybe that was a missed entry. And again, if people are putting in garbage data, then you need to capture that and figure it out pretty quickly, so you can tell straight away there's something going on. Again, 3.5 bedrooms, that's 2 bathrooms, and a lot of times you run into issues like this. People are using characters to describe numerical data. So they're going to say, instead of saying 1 bedroom or 2 bedroom, the number 1 or 2, they're using letters like that. So you have to profile and say, okay, I'm going to have to do some transformation here. And then they may be using non-standard units. So missing values, incomplete data can be empty or null. Outliers or anomalies, like this is an outlier, 2 versus 6 bedrooms versus bathrooms. Unexpected values in the data distribution, 3.5 is definitely unexpected distribution. Incorrect values, inconsistent or non-standard values, mass versus MA, and limited or sparse values, right? All right, so moving on to that. Okay, so I got this data. I have missing values of all these problems. So what do I do to fill gaps in it? So you can do nil versus null. So on data gaps in time series, because remember, you need to be consistent, so you got to fill it in. That seems very, very strange to people. Like, if I don't have the data, how can I fill it in? And there's lots of ways of doing that. So you might use the min, you might use the max, you might use the count, you might use the average, you might use the mean standard deviation. Because remember, like, those are very, very simple to calculate in data. So you can use those to fill in missing values when you're profiling your data. But of course, you have to disclose that. So again, about asking questions about data, data science comes to you and says, yeah, I built this model, so where'd you get the data? Did you do any data profiling? Did you have to fill in any missing values? How did you fill that in? How did you do that? What techniques did you use? If you're filling in a couple of missing values, let's say you got a data set of 10,000 and there was 20 bathroom counts missing, that's fine. 20 is pretty small. But what if it's 20,000 data sets? And yeah, I had to put in the average for something like 5,000. Like you're saying, what if your data set would average? So you got less confidence in that model, because remember, models are all about confidence, and how good your data is can help determine that confidence. So you want to look at accuracy, consistency, completeness, uniqueness, the distribution, the range. Maybe the distribution is off. Maybe people have values in there that are not within that range or distribution. So that's what we call looking at the metadata and determining data types. So tools for doing this are good for an Excel, Google Sheets. I do tell people, even if you don't want to be a programmer, please learn SQL, because it's kind of like learning Excel. It's pretty easy. It's awesome. You can do lots of great stuff, lots of data profiling, manipulation with SQL. You can learn SQL in about a day. And remember, if you're not being a coder, you don't have to worry about updating data and inserting data, well, kind of importing it, you do. But a lot of querying is just about selecting data and transforming, joining data and stuff like that. So super simple to learn SQL. R is great, Python, of course, and then pandas and stuff like that. So, but SQL, Excel, and stuff like that. And you can also use tools like Power BI and Tableau and stuff like that. We'll talk about later. Now, going on from profiling to preparation is something important as well. So data preparation, the process of cleaning, transforming raw data prior to process of analyzing it. So where do data scientists, machine learning engineers, and others spend most of their time? And remember, data science is still one of the sexiest jobs of the 21st century. Maybe it's machine learning engineer. When you do the polls and all that stuff, this is from our friends at Rapidiner. You can see lots of polls like that out, but they spend most of their time collecting data and cleaning and organizing data. So you want to be a data scientist and data engineer. Remember, this is the easy stuff to do. It's where you're going to spend 75%, 85% of your time. And also, a good truism is, like, if you don't like doing this work, then you probably don't want to be a data scientist or data engineer, machine learning engineer, because that's going to spend a lot of time. So data preparation, so you're dealing with missing values when it comes to NA, 0, median value, numeric value. So we kind of covered this a bit already. So here, looking at total basement, it's got NA. So you don't know what that is, you might want to put 0 in it, because if it's NA, the actual basement size is 0, not the average. So be careful about context. Garage area is the same size as well. Does it actually have a garage? So is it good to put in the average size of a garage, or should be 0 as opposed to an NA? And kitchen quality. Here, if most of the variables are TA, 4 out of 6 there, then it's probably a safe bet to put in TA. But again, these are judgment calls. You are the person doing it. So next thing, we want to look at data transformation, because data is often messy and needs to be transformed to a uniform range. So look at your database, right? Similar data is often different formats, that needs to be transformer usable. So think about date and time, right? Different regions use different date time formats. I'm always dealing with that. Georeferences, addresses, locations, spatial data. When I was growing up in Ireland, they didn't even have a thing such called a zip code, right? Postcode in the UK, zip code in the US. Couldn't normalize that. Numeric data. This is the one that drives us crazy all the time. Lots of databases, they actually, it may sound super silly, but there's good reason for it. They have leading numeric zeros because they will say this is stored in 5 numerical characters, and they will put in leading zeros for that. You've got to transform that. You know, when you start working with data, this is it. So this is why always being able to ask questions about this data, understand how it's coming. It's not as simple as you think. And measurement, right? Feet versus meters. So what we then do is we move on to what we call data enrichment, right? So you may not always have the information you need to create successful models. So you want to augment it with additional data. So let's go back to our data set example. So let's say you want to join files from different data sets. It's often hampered by that. So we've got 2 data sets here, one from the US and one from maybe Canada or somewhere else in the US. You straight away, one's got a lot size and the other one calls it a lot area. And we deal with stuff like this, and it's got this, it tells it what the unit is in this one. So if I was going to use this data, I'm going to have to take out that square foot unit, that text, or put it in here so it's uniform, right? This one has the data stored with the full address. This one has it stored by, there's one column for street, one for city, one for stuff like that. So again, you're going to have to merge these data points together. Another one could be building type. This one says a unit of 1 fam, 2 fam. This one here says single, so it's a way of differently describing it. Overall condition, one is using the numerical scale, another one's using categorical scale. So you get the idea. This is super annoying. It takes up a lot of time, but this is the reality of dealing with data. So next time you're yelling at your data analyst or your data engineer, have a little sympathy. This is the kind of stuff you have to deal with. Now, data shaping is something very interesting. If you're using Excel and Google Sheets, you're probably doing data shaping all the time. It generally employs simple functions to gain an aggregate understanding of the data. So condense or summarize data. So think about sums, counts, averages using Excel. Ranges like standard deviation, functions like lookup, VLOOKUP, filtering, searching, sorting. So you're probably doing a lot of data shaping in your day-to-day jobs, right? And so examples of that would be combining and merging variables. So I do it all the time in Excel. I got to combine and merge. So in SQL, use a join or a union. In Excel, you might use a VLOOKUP or lookup. Filtering and sorting columns. So again, you're very familiar with doing that in Google Sheets and stuff like that. But again, a lot of data engineering, a lot of data science, you're required to do this, sorting columns. And then aggregate variables like grouping in SQL, doing a group in SQL, doing a sum in Excel and stuff like that. And then think about if you're an advanced SQL, an advanced Excel or Google Sheets user, you want a pivot table, so you put them on a different axis, especially great for time series data and stuff like that. So pivoting tables is a great example of shaping data. And if you want to be a data guru, then people will respect you. You get a lot of respect being able to just do basic data shaping, right? And again, it doesn't matter if you're just playing around Excel, machine learning, you want to do that. So tools for doing that, as mentioned, Excel and Google Sheets, definitely databases. We use Postgres a lot, SQL, MySQL are all great for that. And if you know how to do it in Excel and Google Sheets, then please learn SQL. Very, very easy. Take a quick course on it. Tableau and Power Bi, as you well know, is great for this as well. They have some free and some paid, but I prefer the earlier ones. And then, of course, you also do this in R, Python, Pandas is great for data shaping because it gives you the mean, the average, and all that kind of stuff. So again, these are some cool tools on this for shaping and preparation. And again, if you want to consult as a data scientist or data engineer or not data engineer, data science, machine learning, stuff like that, a lot of times these projects, what they need is they need data profiling, they need data shaping, data preparation. Like, can you get this data set into a format that I can feed it to my model? So don't worry about having to be a data modeling expert at the very start. So people ask about, let's get to features. So just figuring out how we're doing on time. I know we're running a bit over, but this is kind of where we get into a bit of the machine learning modeling here. So features are individual independent variables. So again, we're back to variables that serve as input to data science and machine learning models. So I really wish I wasn't going so fast here because this is very, very key. So if you understand what a feature is, you've got a big leg up in understanding what machine learning and deep learning stuff is. So simply put, all those variables we were looking at: number of bathrooms, the value, house quality, number of bedrooms, number of trees in the yard. Like, I love to see trees in my yard. Maybe it's not an important feature, but it is something you can measure. These are all what we can call features, right? And simply put, you'll hear when you join ODSC conferences and stuff like that, you'll hear feature this, feature that. Just think in your mind, go to a quiet place and think to yourself, features are nothing more than columns in a data set. So imagine a spreadsheet with columns, right? Not rows, the columns. Every column can be a feature. So the house price data set, all of these are features. They may not be very useful features, but they are features. Remember back when we did correlations, we looked at quality, we looked at the size of the house versus price. The feature there was we're looking at, well, the two features we're looking at: price and size of the house. So this is very, very important. So house price data set. And then feature selection. So any column can be feature. We look at a thing we call feature impact. So this is fundamental, because you can ask a data scientist, and if you don't know about data science, they'll fall off the chair when you ask the question, like, okay, so where did you get your data from? And then what features did you have in your data? And what features did you find impactful? So these are the features that have the greatest effect on model outcomes. The greatest effect, they have impact, they make a difference, right? So if you look at these features here, all of these could have had impact. We're trying to figure out which ones matter. So we're going to focus our efforts on meaningful features that weed out the meaningless ones, right? So remember, simple definition of a simple model is a linear model. Features with strong linear trends tend to work well for linear models. There's tons of types of models out there, but we're going to focus on linear ones for a simple example. So the one we looked at was, again, kind of said this earlier, but area versus price there. So you can see this is a very simple correlation. It's linear. It's got very, very strong momentum direction. So this is a good one. So you can definitely say that area has impact, right? You may say something like number of trees in the yard. I think an example of it later, but that had no impact. That line would have been flat or going top right to bottom, top left to bottom right. There's another very cool feature to understand machine learning. It's called the target feature. So in a feature data set, the target feature, our target variable, is the thing that we're trying to predict. And that thing we're trying to predict in these basic algorithms we're looking there, it's also an input to the algorithm. So the algorithm learns the relationship pattern between the target and the other feature to create a model. So remember, we talked about using data to learn patterns yourself. With machine learning, that's all it does. It just learns a pattern. So simple example of this is, again, our housing data set. These here in green, lot area, all the way up to garage, these are what we call our input features. We after doing some correlation analysis and stuff like that, we believe they all have impact. But now we're going to put them in together and see what happens. And what are we trying to predict? We're trying to predict sales price. So again, we'll get into the fact that, well, if you're already trying to predict it, how do you already have it? But what we're trying to predict is sales price. So this is our target feature, right? So we feed in this house data, which are features, and then we feed in the prior sales price, which is our target. Then we put that into let's say a linear regression model, and then we produce what we call a model. So remember, everyone else, we use algorithms and models interchangeably. But the algorithm is really the model the algorithm really is and now I just did it again, is the function you're using to learn. You feed it in the features, again, the stuff in green, and you feed in the sales price, because what it's trying to do is learn the pattern between sales price versus all of these. So that way you're telling the model, hey, I'm going to tell you the number of bedrooms, bathrooms, garage, condition, all that stuff. And the price was 100,000. This other one has got different set of parameters, different set of variables, features, and at a price of 200,000, this one had $1 million, right? So what you're doing with that is you're producing this model, and then we'll talk a bit about the model. So again, you know, if you take one outcome from this, and again, if you're not a machine learning, if you don't know about machine learning data science, this is really key, making machine learning accessible to you. So machine learning allows algorithms to learn from experience. So what's the experience? The prior results, prior sales prices, based on prior size of the house and bathrooms. It learns directly from features without relying on a set of predetermined rules. And the algorithm adaptively improves the performance, learns as the number of features and the amount of data available becomes available increases. So the algorithms that run is learning, right? So if you give me 10,000 house prices today, I'd build a model, pretty good one. And then tomorrow, if you give me another 50,000, it will learn better, then another 100,000. So that's why data set size is so important to a lot of these models, especially deep learning. So looking at our machine learning model again, data input are the features, target variable. We input our features, we input our target variable. We want to output a learn model. And to do that, we're putting in the house data, we're putting in the prior price, and now we come out with a house price prediction model. And I have a slide for this. I'll explain more on the machine learning literacy course, but just to understand this, now with this model here, let's say a friend of mine comes to me tomorrow and says, Seamus, I'm selling my condo in Cambridge, Mass. It's got 2 bedrooms, it's got 2 bathrooms, it's got no parking, no basement. It's 1,000 square feet, a garden. How much is the price going to be? I can be pretty assured, without never have seen that apartment, never seen that actual place before, I can say, well, based on prior results in the model we have, and we've got pretty good data for Cambridge, the price of that condo is going to be like $700,000. And that's essentially, now you know how machine learning works. There you go, that slide. So remember that the keywords are, you know, features or column in a data set, column, any column in a data set, spreadsheet, those are the features. The target variable tends to be a feature as well, because that's there's other kinds of models we don't have a target feature we'll talk about later, but in fundamental models, you know what the target feature is. So let's say you're trying to predict the sales of the best sales price, or you're trying to predict the stock price of a stock. You're looking at previous stock prices to predict the future stock price. So a lot of models are built on this, so you'll get quite far with that. Let's talk super fast about big data and wide data. Data has columns and rows, right? So if you got a ton of columns, like let's say you got 5 rows, let's say you got 50 million rows and thousands of columns, that's big data. If you got lots of columns, thousands of columns, that's called wide data. And you'll keep hearing this term, it's called high dimensional data. And like, that used to confuse the hell out of me. What's high dimensional about? It's like high frequency. No, it just means it's wide data, which just means it's got many columns. So when people say high dimensional data, think lots of features, lots of columns, pretty simple. Hundreds if not thousands of columns, and many features to select from. And that's a problem, because remember, like if you're selecting from 20 features, now all of a sudden you got to select from thousands of features. Like that's why, you know, data profiling and transformation is so important, because forget about modeling, you got to do feature selection and feature engineering. You got to work with a lot of these things. Shallow data is when we have relatively few rows versus columns, and it's challenging to decide the optimal features, because with a given feature, like if you only had 10 rows for a number of bathrooms, it's kind of going to be hard to determine a good model, pricing model based on the number of bathrooms. And you want to also determine if the data is uniform or very little variation. So there's a whole discipline around this we call dimensionality reduction, such as principal component analysis and all that kind of good stuff. So feature engineering, feature selection. I think about a housing data set. A lot of housing data have what they call homeowner association fees, and then they have all fees, but a lot of houses just have that fee. So maybe there's a second fee, there's a pool, so maybe it's $350, but I think I got these 2 data sets and they're basically the same. So I can go for one feature, which is all fees, and drop the other one. If data is not varying a lot, you can drop that. If it's kind of close, if the data is kind of same, close, the prices are, you know, within a small margin of error, you can shrink that. So that's how dimensionality reduction goes. This is more varied, so you wouldn't want to reduce that. So it can reduce the number of observations, reduce the number of features for you. So we can kind of go over that. Yeah, so if you want to learn, if you want to go to, so we covered data lifecycle, we covered data profiling, we covered data preparation, we covered features, and we covered data shaping. And just want to give you a teaser of what comes up in the data literacy, but you'll see like feature engineering is very much in model tuning, but we talked here about the machine learning workflow, which every machine learning engineer or data scientist learns. Like the first part is data prep, feature selection, model training, model evaluation, deploy to production, and then model prediction and production model monitoring. So data is very central to all of these, and we'll cover this in our machine learning literacy course. A couple of books to review. Check out Excel data analysis, because before you start grappling with all these books are available in PDF format. You can of course buy them if you want to support the if you want to support the author, buy them, but they haven't made available for free. And I'm just looking here to see if I can, because I do have copies of 2 of those books, which I want to see if I can upload to here. Ira, can I upload files if you're still on? Maybe you're not still on. Can I upload files to GoToWebinar?
You may send the links or
no,
upload the files. No, I don't think so. We need to do it.
Yeah, if you do, yeah, these are freely available. So I'll give you $2 to include in the recording. But the 2 I have is Excel for data analysis and data mining, because I think if you're going to become an expert in data, like, you know, if you already know Python, then go ahead and learn pandas or Python. But just, and again, you know, you don't have to read these books cover to cover. I seldom read books cover to cover these days. But I do find they're very good for scanning and for doing deep chapter dives. So these 2 are good: data mining and Excel for data analysis. The 2 on the right kind of get more technical, to get more formulaic around mathematics, but they're also quite good. So if you can take a screenshot there, again, we'll have this recorded. You know, don't go into, you know, machine learning books, because if you want to just focus on the data first, stay away from the machine learning stuff at the start and just focus on the data, because these books will talk about filling in missing data, how to do data analysis. Because one of my core beliefs is, and you see this all the time in job descriptions, they keep saying is a core requirement for a machine learning engineer or data scientist is you need to be good at data analysis, simple, basic data analysis. Because you'd be surprised, people go through machine learning, like you go from, you get a degree in machine learning or data science, you're focusing all on the math and the models, and you're not really doing any fundamental data analysis. So that tends to be a big gap. Data and SQL tends to be a gap on that. Yeah, my last point is question the data. How is a gathered profile shaped and transformed? You know, because again, going back to Dilbert, so I just made this up. All right. And honestly, this is kind of funny, but you see stuff like this all the time, where people, I'm not saying they're faking the data, I'm not saying they're doing it on purpose, but you really want to question data, how these models produce things. You will see over the coming years, and we'll see it, there's loads of problems around all this kind of stuff.